In our previous video, we discussed the difference between linear dynamics and rotational dynamics in terms of mass and rotational inertia. In linear dynamics, when we want to accelerate an object, its inertia makes it either more difficult or easier to accelerate depending on how much inertia it has. More mass means an object has more inertia, less mass means an object has less inertia, and in that case would therefore be easier to accelerate. When we look at rotation, however, as was mentioned in the previous video, you not only look at the mass of the object, you also have to consider where that mass is located. And combining those two things together gives us a concept called rotational inertia. As a side note here, this is also sometimes called the moment of inertia. However, in AP Physics 1, they list it as rotational inertia on your AP formula sheet, and therefore that's what I'm going to refer to it as in our class. If you're taking AP Physics C, I believe you will be using the term moment of inertia, however. So when we use this in a formula, the symbol that we're going to be using is a capital I. Units for rotational inertia for all objects end up being kilograms multiplied by meters squared, kilogram.meter squared. And in calculating the rotational inertia, it's based on these two different things. First of all, the mass of the rotating object, and then what you're going to be using is the radius or length of the object. And here's the thing, different shapes have different rotational inertia formulas. The good news, however, is you do not need to memorize any of these formulas. You will see that they're not on your AP formula sheet. So here's the deal. If you need to know a rotational inertia formula on your AP test, it would be given to you in the problem that you're doing. So if they don't give you the rotational inertia formula for an object in the problem that you are doing on the AP test, then you do not need a rotational inertia formula. So don't try and pull it out of your memory because you should not need it then. The exception to this will be if we're doing an MP problem. If they don't give you the rotational inertia formula in the problem, there are some cases where you sometimes do have to look it up in there, but specifically for the AP test, you do not need to memorize any of these formulas. And I say that because on my next slide here, I give you an example of a whole bunch of these different formulas. Now, where do these formulas come from? They come from calculus. In this class, you don't need to develop any of these formulas. You do not need to derive any of these formulas. If you're taking AP Physics C, though, and you know some calculus, or you're learning some calculus while you take AP Physics C, they do have you derive these formulas using calculus. So if you look at the column on the right, you just see, okay, well, if they give you a problem where there's a thin hoop and you somehow have to calculate the rotational inertia or moment of inertia of the object, of the thin hoop, you're just going to take the mass of that hoop and multiply by the radius squared of the hoop. All right, you're going to keep it in standard units, kilograms and meters. You're probably not going to get something that is a little bit more difficult where you have to deal with the width of the hoop, which is our second example here. In order to get the rotational inertia of that object, you have to do two different calculations, add them together. I've never seen anything like that in AP Physics 1, so I wouldn't worry about it. I would say the most common ones you're going to see are the thin hoop, the solid cylinder. Here, let's highlight those. Thin hoop, solid cylinder. You could see a uniform sphere. That has been given on an AP test before. It could be a rod with the axis through the center. This is kind of like what Ben was doing in the video today, except we had those big weights at the end, so not quite the same. It would be a different formula. You could have a rod that has an axis at the end, and so that rod is rotating around that axis, and we get that formula. I would say out of this list, these are the ones that you would be most likely to see. All right. So, like I said, don't memorize it, but if you end up having to use rotational inertia in a problem and you need a numerical value for it, and it hasn't been given to you directly, well, there's two possibilities. You either need to calculate it using the mass and radius of the object or the length of the object, or it's what you're solving for in the problem, and there are other ways to get it, which we will talk about in future slides. But this is the direct way to calculate rotational inertia if you have mass and radius or length of the object.